Right, so in this question here, it says find the length of the side CF of the rectangle. So basically we want this side here, the rectangle, okay? And because it is a rectangle, we can put a right angle there. And notice then we've got like a triangle, haven't we? Right angle, triangle, and we know this longer side, we know the hypotenuse. And I can actually work out this side as well, can't I? I can work out DF here, okay? Quite simply, this length here, subtract this length. So DF will equal 15.7, take away 12.5. Okay, so my calculator, I get 3.2 centimeters. So 3.2 there. And I hope you can see then, you can use Pythagoras then to get DF. Okay, so when you use Pythagoras, of course the longer side there, 8.4 squared, will equal then the sum of the squares of the two shorter sides. So 3.2 squared for this side here, squared, and then that side there, CF, all squared, don't forget, right? So then, what I do now, before maybe working this out, I'll take that over the other side and take away. So work that out on my calculator. And I get 60.32. To get CF then, you're going to take the square over and square root. And I get 7.8. We'll go for one decimal place. Then it says calculate the area of the parallelogram ABCD, clearly stating the units of your answer. Now the parallelogram area formula is just base times height, okay? And it's a bit like a rectangle, isn't it? Length times width, but parallelogram is like a rectangle that's been pushed over. And it's important that you do get the base. So the base here would be AD, but you also need the height. So that slant there is no good, right? Because that's not how you measure the height on the slant angle there. You need the perpendicular height. So the base, of course, it's a bit like a triangle, isn't it? That's why we say base times height. You need the base, but the height needs to be perpendicular to the base, and the height is just the same as CF that we just worked out. So it'll be 15.7, and use the right one, yeah? Have I chosen the right one? I've chosen the wrong one, haven't I? Because I need this here, yeah? AD, right? So easily gone wrong there. I've gone too far across. That's not my base, isn't it? Because it goes beyond my base. My base is just this, what's on the ground here, okay? What's touching the ground. So AD, so 12.5. So get rid of that. So easily mistakes made there, right? So just watch out for things like that. 12.5 for the base. Height then is 7.8, which we just worked out. My calculator. And that comes to 97.5. It says units. Of course, put them in then, centimeters squared. Part B, it says calculate the area of the quadrilateral ABCD. Now, the only way you can do this in a really simple way, right, is just to draw a line down here, okay? When you draw a line down there, you could see they are two triangles, okay? It's got nothing to do with Pythagoras, this. You don't need to do Pythagoras, okay? You just treat it as two triangles. If I call this triangle 1, triangle 2, triangle 1 is easy to see, area of 1. Now with a triangle, of course, base times height divided by 2. That's the formula for a triangle, half base times height. So in this case, it's clear, isn't it? The base is 10.4, height is 7.8. You've got to halve it. So we'll work that out in a minute. Area 2. Now the triangle is sort of being tipped over, but it's the same sort of thing. The base would be 12. Height of it is perpendicular to the base, so that's 5. Divide by 2. Okay, so I know that's 30 centimeters squared. So the other one then, you get 40.56. Of course, to get the total area then, you need to add them, right? 40.56 plus 30 is 70.56 centimeter squared.